Have you ever heard of a perfect square? Well, a perfect square is actually just the result of squaring a number. The trick is to find out which number has been squared. Now before, remember when I wrote 5 squared, 5 to the second power, and I said that can also be said as 5 squared. And we said 5 times 5 is 25. Well, 25 is the perfect square. The perfect square of 5. Now sometimes you're going to run into a number that you may not know. Maybe 18. Is 18 a perfect square? Not sure. What we can do is try to remember all of our perfect squares, or try to remember all of our numbers that are squared and what they turn into when we square them. You can write them all down. 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, and so on. Or you can refer to the list that is in the module of all your perfect squares, and it has all your perfect cubes too. I think up to maybe 15. So let's look at this situation here. We got 18, and we're trying to figure out if it's a perfect square or not. Well, remember, the perfect square would be the result of squaring a number. Well, 18 is after 16 and before 25. Remember, 16 is the result of squaring 4, and 25 is the result of squaring 5. 4 or 5, there's no number in between, no integer in between 4 and 5 to square. So therefore, 18 does not represent the square or the perfect square of any integer. So therefore, 18 is not a perfect square. Okay. So what about the number 8? Is 8 a perfect square? Well, here is 4 and 9. 8 is right before 9. Doesn't represent a perfect square of any integer. So 8 isn't a perfect square. But 8 is a perfect cube. So we got 1 cubed. 1 cubed is 1 times 1 times 1. That's obviously 1. 2 cubed. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2, that is 8. 8 is the perfect cube of 2. Let's do another one. 3 cubed. 3 cubed is 3 times 3 times 3. 3 times 3 is 9. Almost jumped ahead of myself. And 9 times 3 is 27. 27 is the perfect cube of 3. So that's how we figure out what our perfect cubes and our perfect squares are. So go into the exponent module, and under perfect squares and perfect cubes, download your list of perfect squares and perfect cubes so that you can start to memorize your perfect squares and perfect cubes and then decide which ones are and which ones are not.